The role of international standards in tackling e-waste. E-waste, when treated inadequately, poses serious health issues since it contains hazardous components. These risks include the contamination of air, water and soil that puts people's health at risk. Dismantling processes that do not utilize adequate means, facilities, and trained personnel pose additional threats to people and the planet. It has been observed, for instance, that improper management of e-waste can have severe effects, such as causing allergies, respiratory diseases, and even cancer. Furthermore, leaching, open-air burning and heating, as well as uncontrolled discharge of scrap, acids, cyanides and other byproducts from processing operations pollute the soil, groundwater and food. Consequently, if not treated properly, e-waste could have significant negative environmental, economic, and social effects. The threat of e-waste has grown rapidly over the past 2 decades, particularly with the widespread adoption of information and communication technologies, from mobile phones to digital devices. The use of ICT equipment and products comes with an unknown rate at which these gadgets become obsolete due to technology advancements, and hence the need to be replaced by their owners. This has led to an enormous increase in e-waste, with 62 billion kilograms, or 62 million tons, of electronic waste generated globally in 2022, which translates to about 7.8 kilograms per person. What's more concerning is that only 22.3% of this e-waste was formally collected and recycled in an environmentally sound manner. This makes e-waste one of the fastest growing waste streams worldwide. Despite the growing levels of e-waste, the recycling rate for e-waste is still very low around the world. In 2022, only 22.3% of e-waste was formally collected and recycled in an environmentally sound manner, a slight increase from the 20% reported in 2016. But still far from sufficient. While 81 countries have now adopted e-waste policy, legislation or regulation, only 67 countries have specific legal provisions on extended producer responsibility, a key mechanism to make producers responsible for post-consumer waste. Moreover, just 37 countries have provisions on e-waste recycling rate targets, and only 48 countries have collection rate targets. This is concerning, given that effective recycling of e-waste has demonstrated direct positive impacts on the environment, economy, and society. It is imperative, therefore, that all countries establish or reinforce their national e-waste management systems. Improving the effectiveness and pervasiveness of national e-waste management systems will contribute to counteracting and preventing illegal shipments of e-waste. These illegal flows disproportionately affect developing countries due to the presence of low-cost, low-skilled labor and loose environmental, health and safety requirements and controls. Recycling e-waste, on the other hand, offers direct business development opportunities for communities, thus contributing to job creation. For example, sorting and processing recyclables alone generate 50 times more jobs than landfilling or incineration. Another example is that computer reuse and recycling creates nearly 300 more jobs for every 10,000 tons of material disposed each year. E-waste is also an economic opportunity in other respects. For example, equipment can contain rare metals, such as gold, silver and lithium, as well as base metals, such as copper, lead and zinc. In fact, e-waste is a rich source of precious metals compared to primary ores. In fact, 1 ton of end-of-life mobile phones can contain up to 141 grams of gold, whereas 1 ton of gold ore typically yields only 5 grams. In practical terms, This means 1 ton of smartphones contain 300 times more gold than 1 ton of gold ore. At the individual level, we can do our part by applying to e-waste the same general principles of recycling that apply to other types of recyclables. Reuse. This means using things more than once. Reduce and repair, refurbish. This means using fewer resources in general. Recycle. This means properly separating waste materials. Prevention, especially, is paramount. Given the concerning levels in the growth of e-waste that we have seen in previous slides. Together, on a macro level, the issues around e-waste can be solved under the guidance provided by instruments such as the 2030 Agenda for Sustainable Development, which was adopted by the United Nations and all member states in September 2015. This ambitious agenda identified 17 Sustainable Development Goals and 169 targets meant to end poverty, protect the planet, and ensure prosperity. Increasing levels of e-waste, its improper and unsafe treatment, and its disposal through incineration or in landfills, poses significant challenges to the achievement of these Sustainable Development Goals. A better understanding and management of e-waste is closely linked to the following Sustainable Development Goals. Goal 3, Good Health and Well-being, in which, Target 3.9, for example, refers to the reduction of the number of deaths and illnesses caused by hazardous chemicals and air, water, and soil pollution and contamination. Goal 6, Clean Water and Sanitation, in which Target 6.1 seeks to achieve universal and equitable access to safe and affordable drinking water for everyone, and Target 6.3 which aims to reduce pollution, eliminate dumping, and minimize the release of hazardous chemicals and materials. Goal 8. Decent work and economic growth, in which Target 8.3 aims to promote development-oriented policies that support productive activities, decent job creation, entrepreneurship, creativity, and innovation, and to encourage the formalization and growth of micro, small, and medium-sized enterprises. Target 8.8, which calls for the protection of labor rights and promotes safe and secure working environments for all workers, including migrant workers, and particularly women migrants and those in precarious employment. The sound management of e-waste can create new employment and contribute to economic growth in the recycling and refurbishing sector. Goal 11. Sustainable cities and communities, in which Target 11.6 aims to reduce the adverse per capita environmental impact of cities by paying special attention to air quality and municipal waste management, for example. Since over half of the world's population lives in cities, rapid urbanization requires new solutions to address rising environmental and human health risks, especially in densely populated areas. Most e-waste will be generated in cities. Therefore, it is particularly important to properly manage e-waste in urban areas, improve collection and recycling rates, and reduce the amount of e-waste that ends up in dump sites. The move towards smart cities and the use of ICTs for waste management can offer new and exciting opportunities in this regard. Goal 12. Responsible consumption and production, in which Target 12.4 aims to achieve the environmentally sound management of chemicals and all waste throughout the life cycle, in accordance with agreed international frameworks, and to significantly reduce their release into air, water, and soil in order to minimize their adverse impacts on human health and the environment. Target 12.5, which aims to substantially reduce waste generation through prevention, reduction, repair, recycling, and reuse. An increasing number of people on the planet are consuming growing amounts of goods and it is critical to make production and consumption more sustainable by raising awareness levels of producers and consumers, specifically in the area of electrical and electronic equipment. And lastly, Goal 14. Life below water, which refers to marine pollution and the protection of the marine ecosystem, especially in its targets 14.1 and 14.2. It should also be noted that e-waste is often processed in the informal sector, and many e-waste disposal and recycling jobs are unsafe and not protected by formal regulation. It is therefore necessary for countries to formalize the environmentally sound management of e-waste, and to take advantage of the business opportunities that it offers. The Connect 2030 agenda is another instrument vital to globally addressing the issue of growing e-waste.
The Connect 2030
This
agenda
Connect
is another
2030
instrument
agenda
vital
is a
to
global
globally addressing
initiative
the issue
headed by
of
the
growing
International
e-waste.
Telecommunication
This
Union,
Connect
more
2030
commonly known
agenda
as the
is a global
ITU.
initiative
It
headed by
sets
the
out the shared
International
vision,
Telecommunication Union,
goals and
more
targets for
commonly
global
known as the
telecommunication
ITU.
and ICT
It sets
development
out the
that
shared
UN member
vision,
states
goals,
have
and
committed to
targets
achieving
for
by the
global
year
telecommunication and
2030.
ICT
The Connect
development
2030
that UN
agenda
member states
promotes
have committed to
universal,
achieving by the
secure,
year
reliable,
2030.
and affordable
The
connectivity
goal
as
of the
key
Connect
to
2030
accelerate
agenda is
sustainable
to
development worldwide
increase the
to
global
achieve
e-waste recycling rate to
universal
30%
connectivity by
and
2030,
raise the percentage of
sustainable
countries
digital
with e-waste
transformation by
legislation to
2030, in
50%.
particular significant improvement in tech and telecom contributions to climate and environmental action. Other important bodies and work guiding the reduction and recycling of e-waste around the globe include the UN E-Waste Coalition, that ITU is part of, which calls for increased collaboration, building partnership and supporting UN member states to address the global e-waste challenge via three core functions: advocacy, knowledge, and intervention. The United for Smart Sustainable Cities initiative by the ITU and UN, commonly known as U4SSC, provides an open platform for city smartness and sustainability progress. The Green Digital Action launched at COP28 puts e-waste and the circular economy at the heart of a global collective effort to ensure the digital revolution supports global climate and sustainability goals. As a collaborative initiative, it offers a platform for cross-sectoral cooperation, essential for tackling complex issues like e-waste and building a more sustainable digital future. In the remaining slides, we will focus on the work of the International Telecommunication Union, ITU, which is the specialized agency at the UN for all information and communication technologies. As you can imagine, ITU's overall work is very comprehensive, a big part of which is standardization via its telecommunication standardization sector, commonly known as the ITUT. Within ITUT, Study Group 5 is the lead expert group on developing standards and guidelines to tackle e-waste worldwide and achieve a circular economy globally. Events such as the annual Green Standards Week and the Symposium for ICT, Environment, Climate Change and Circular Economy act as a global platform where policymakers, field experts, city planners, regulators, standards experts, civil societies, and others can come together to discuss the role of information communication technologies and frontier technologies in facilitating environmental sustainability and climate action. Additionally, the Green Digital Action Initiative, led by ITU, is a multi-stakeholder collaboration to step up climate action across the global digital community. Several other events similarly hosted by ITU serve to raise awareness on the intersection of technology and climate change and the environment, including issues such as e-waste and the circular economy. ITUT Study Group 5 has developed a variety of recommendations related to the issues around e-waste, ICTs and the circular economy, and is in the processing of developing more. that can be seen on this slide and the next two. In this presentation, we will be focusing on the 3 recommendations circled in red. Recommendation ITUTL 1021, Extended Producer Responsibility, Guidelines for Sustainable E-Waste Management. Recommendation ITUTL 1030, E-Waste Management Framework for Countries. Recommendation ITUTL 1031, Guideline for the Development of an E-Waste Management System and Achieving the E-Waste Targets of the Connect 2030 Agenda. This is a continuation of the Study Group 5 recommendations on tackling e-waste and achieving a circular economy. Some of these recommendations will be covered in other courses within this series.
These can be seen on this slide and the next. In this presentation, we will be focusing on the 6 recommendations that fall under the ITUT L1000 series that is circled in red on the chart. The L1000 series recommendations are designed to ensure that the Universal Power Adapter solution operates within the recognized current and voltage safety parameters by adopting existing ICT device technologies and by considering operators, manufacturers, and associations working within the market. All the recommendations have been set with the aim of reducing e-waste and increasing usability.
This slide is also a continuation of other ITU standards on e-waste and circular economy.
Related to the issues around e-waste, ICTs, and the circular economy, and is in the process of developing more. These can be seen on this slide and the next. In this presentation, we will be focusing on the 6 recommendations that fall under the ITUT L1000 series that is circled in red on the chart. The L1000 series recommendations are designed to ensure that the Universal Power Adapter solution operates within the recognized current and voltage safety parameters by adopting existing ICT device technologies and by considering operators, manufacturers, and associations working within the market. All the recommendations have been set with the aim of reducing e-waste and increasing usability.
We will proceed in this course with recommendation ITUTL 1021. This recommendation offers a description of the extended producer responsibility system in dealing with e-waste. It expands on the different existing forms of extended producer responsibility globally, with a practical view on their feasibility, challenges, and prerequisites. It elaborates on the definition of the extended producer responsibility system, which you can see here on the slide in brief. In addition to the roles and responsibilities of the different stakeholders and the different types of extended producer responsibility, the funding mechanism behind every mode and the organizational structure expected to be in place are also presented. This recommendation concludes with many best practices from the international arena, including developed, developing and emerging economies, as well as the challenges faced in some cases. Extended producer responsibility implementation models in terms of responsibility and compulsiveness include the following considerations. Voluntary versus legislation or compulsory extended producer responsibility implementation schemes can be implemented on a voluntary basis, often via corporate social responsibility. However, more and more countries are considering extended producer responsibility as mandatory or a combination of both, such as negotiated agreements between governments and industries. Across Europe, extended producer responsibility is compulsory via legislation, and regulations vary from imposing physical responsibility to imposing financial responsibility. Individual producer responsibility versus collective producer responsibility. Extended producer responsibility models may also be based on the efforts of individual producers, where each producer is responsible for their line or product category, or based on collective efforts and platforms in the form of combined extended producer responsibility programs. Such programs are known as collective extended producer responsibility schemes, whereby entities such as producer responsibility organizations or third-party organizations are established to conduct collection or take back, as well as dismantling and recycling on behalf of the producers at the level of an industry. Alternatively, producer responsibility organizations organize and administer the collection and recycling of waste on behalf of producers by subcontracting collection companies and recyclers. A fee is typically charged for their services. These costs include those of collecting and processing voluntary or mandated product take-back systems. A popular extended producer responsibility may receive income from the sale of recyclable materials to recycling companies. It gives the physical responsibility for electronic product disposal at the end of its useful life to the producer or a collective body of producers, along with the financial responsibility of reuse, recycling and final disposal. A take-back system is made up of four main features, including collection, processing, including pre-processing and end-processing, managing the flow of products and sustainability of the system, and financing schemes. Producers are responsible for setting up a supportive system for collection, take-back and recycling, processing. Governments may require each producer to meet specific recycling or collecting rate targets, either on a voluntary or mandatory basis. If producers do not have a direct connection with an end user and where products sold do not replace existing products, it is hard to define collection rate targets. Some extended producer responsibility implementation programs provide incentives for consumers to return the used product to a specified location, such as the selling point. In this context, take-back regulations sometimes mandate that particular product components be recovered and recycled. It is important to note that waste electrical and electronic equipment is the most frequent target of take-back regulations and systems globally. For example, the European Union has mostly adopted extended producer responsibility take-back systems. This slide will speak to the roles and responsibilities of the four main stakeholders in the extended producer responsibility system. Producers. The responsibility of producers consists of design, management and finance schemes, as well as programs for end-of-life management of their products as a condition for sale. The producer can have financial or physical responsibility or both. The producer is also held liable to environmental damage through the polluters pay principle and its costs. In addition to having the liability to inform retailers and customers about the environmental repercussions of their products. Retailers, vendors, and importers. Retailers and vendors can have the option of selling product brands that are made by producers that have a form of extended producer responsibility implementation scheme, such as take-back systems. Vendors and retailers have the responsibility to inform customers of how to access information on take-back systems and the recycling of products after usage. Consumers. Consumers have a responsibility to use electronic products in such a way as to reduce waste, promote the reuse of products and make conscious purchasing decisions based on available information about product impacts and benefits. If the products they purchase incorporate take-back or other collection and extended producer responsibility programs, then they should return the used products to ensure a safe and environmentally sound end-of-life management process. Governments. The regulatory and operational roles of governments are important in an extended producer responsibility system for its effective operation. Generally, governments are responsible for putting regulations and mandates to introduce and enforce extended producer responsibility. The government can even design extended producer responsibility implementation schemes, or it can be left to producers to design their own. The government should set performance requirements for producers and should act as an enforcer to ensure that extended producer responsibility implementation initiatives and systems are operating with maximum efficiency, but with minimal government intervention. Governments should also be responsible for information dissemination on extended producer responsibility, providing incentives to the private sector and producers, and for educating the public on extended producer responsibility and its importance. Setting standards and certification to formalize the process and putting a strategic framework for extended producer responsibility mainstreaming into the e-waste management system should also be a governmental responsibility. On an operational level, governments are also responsible for promoting and facilitating collection and recycling at end of life, and to prevent the disposal of end-user products in regular waste. This slide shows the various phases of the take-back system suggested in the recommendation. The collection for take-back phase includes permanent drop-off facility, special drop-off events, special drop-off points, door-to-door collection. The processing phase includes pre-processing, that is, separation of products, primary dismantling, secondary dismantling, end processing, that is, reuse and recycling of components, recovery of precious metals, exporting components, final disposal through landfill or incineration. The management phase includes producer responsibility organizations, producers individually, government entities. Lastly, financing schemes includes financing methods that entail adopting eco-designs that are cost-effective to offset the costs of extended producer responsibility, or using recycling materials to offset the costs of extended producer responsibility. This slide outlines the advantages and disadvantages of full versus phased implementation of the suggested take-back system. Full scope. Advantages includes that it covers all products and does not need further legislation when new product comes on market or if a new environmental problem is identified. Disadvantages includes that it adds complexity to the system, adds strain to recycling infrastructures, and leads to focus on recycling of non-problematic but valuable fractions. Phased scope. Advantages includes that it focuses take-back system on specific product types, groups, can allow for iterative build-up of scope and infrastructure in parallel, and can ensure that problematic products and fractions are dealt with as a priority. Disadvantages includes that it leaves large part of the e-waste without an official take-back system, and may leave some reluctant to move on to full scope. This slide outlines the advantages and disadvantages of management of the suggested take-back system by government versus non-government parties. Management by government has the following advantages. Governments have powers of enforcement, levying fines and banning non-compliant producers. There are no potential conflict of interest, in theory. Disadvantages. Management by government adds complexity to the system. Management by government adds strain to recycling infrastructures. Management by government leads to focus on recycling of non-problematic but valuable fractions. Management by third-party organizations has the following advantages. Third-party organizations are all flexible. They can adjust rules and outcomes more easily. It is easier to develop relationship with relevant stakeholders. Third-party organizations have strong business incentive to minimize costs while optimizing operation process. Disadvantages. Third-party organizations lack the enforcement mechanisms that government enjoys. There is potential excessive focus on third-party organization members, wherein stakeholders and the community's concerns may be ignored. There could be potential conflict of interest. In conclusion, there are many benefits to implementing an extended producer responsibility system. These include environmentally friendly or eco-designs to encourage cost-effectiveness and pollution prevention, use of non-toxic materials and processes, innovation for more efficient design and production, improved resource efficiency, material inputs and energy consumption, reduced pollution from production and waste treatment, manufacturing of more durable products, manufacturing of more reusable and recyclable products, responsible usage of electronics, reuse and refurbishment of used products, minimal disposal to landfills or incineration, safe disposal of harmful materials, creation of profitable business opportunities and a recycling industry niche, and contribution to a circular economy that promotes sustainable production and consumption, thereby directly contributing to the fulfillment of the United Nations Sustainable Development Goals. Developed, emerging and developing economies differ in the way they address and implement an extended producer responsibility system. This point should be carefully taken into consideration for a suitable tailored solution. The most important challenges facing developing and emerging markets include the lack of knowledge and awareness of extended producer responsibility and its models of implementation at the government and public levels, need for access to information, knowledge sharing and studies to suggest extended producer responsibility frameworks suitable for different contexts, lack of a pool of experts that can promote and support the design and implementation of extended producer responsibility schemes, need for a champion or a platform that can lobby for extended producer responsibility related policies with producers, manufacturers, and local industrialists. Unavailability of a market readiness study to assess the suitability and readiness of local producers in designing and adopting extended producer responsibility and related take-back systems. Lack of existing incentives to encourage producers to adopt extended producer responsibility related schemes. Lack of existing bodies that can be considered as collective producers' platforms to implement and operate extended producer responsibility programs. Lack of existing know-how and institutional capacity to operate and support the implementation modes of extended producer responsibility, both private and public. High cost of operation of extended producer responsibility programs due to multi-stakeholder involvement. Need for regulations and government-level policies to support the design and monitoring of extended producer responsibility programs. Lack of integrated e-waste management, including the unavailability of proper nationwide collection systems, dismantling and treatment facilities, and precious metal extraction technologies. Predominance of the informal sector in collection and treatment of e-waste with dire health and environmental hazards. The second recommendation covered in this presentation is Recommendation ITUTL 1030. This recommendation provides an e-waste management framework for countries. It summarizes the different steps that countries need to adopt in order to put in place an e-waste management system, with those steps then further elaborated in other recommendations. In addition, this recommendation provides highlights concerning the environmental impact of the improper handling of e-waste, as well as the economic opportunities that could emerge from the sustainable management of e-waste. This recommendation is also meant to address the ICT divisions within countries, which could play an important role in designing and facilitating proper e-waste management systems, in cooperation with the entities in charge of the environment. As a preliminary step for the preparation of drafting e-waste management legislation, countries must Identify sources of e-waste generation and compile an inventory of e-waste in the country, keeping in view the categorization explained under Recommendation ITUT 1031. Consult producers, traders, service operators, academia, industry associations, voluntary producer compliance schemes, municipalities, collection and treatment facilities operators, informal operators, that is, collectors, dismantlers, recyclers, and scrap dealers, consumer associations and civil society organizations, ensure the availability of public funds to promote cooperation among competent ministries and enforcement agencies, for example, customs, police, organize nationwide. Publicly funded awareness-raising campaigns to inform consumers of available e-waste collection points and of the risks that improper handling and management of e-waste may cause to human health and the environment. Define incentives for adequate collection, and assess e-waste technologies, practices and skills already available in the country, compiling an inventory of available collection and recycling facilities, name, address and specialization, available repair, dismantling and treatment technology. Conduct a survey to assess the level of expertise of personnel in collection and recycling facilities. Conduct a cost-benefit analysis of different e-waste management system designs. Considering economic, environmental and social factors, including potential job creation or suppression in each economic sector involved. Estimate the size of the informal sector and evaluate the possibility to collaborate with and/or empower them. It is possible to derive the amount of waste electrical and electronic equipment handled by the informal sector from the estimate of waste electrical and electronic equipment generated. The latter can be estimated via a multivariate input-output analysis, including sales, stock size, stock age composition, lifespan profile, quantity of e-waste generated and e-waste age composition. Extend the scope of public agencies and authorities to include e-waste. Establish a register for all stakeholders addressed by the legislation. Recommendation ITUTL 1031 describes a three-step approach to addressing the e-waste reduction target of the Connect 2030 agenda. These steps consist of guidance on developing an e-waste inventory, approaches to designing e-waste prevention and reduction programs, and the supportive measures required for successfully implementing the Connect 2030 e-waste target. This recommendation is intended to be utilized by relevant stakeholders to take their first step in addressing Target 2.5 of the Connect 2030 agenda, which is to significantly improve the tech and telecom contributions to climate and environmental action. Recommendation ITUTL 1031 describes a three-step approach to implement a reduction target for e-waste. Step 1 includes guidance on developing a six-step e-waste inventory. This involves defining scope and boundaries, collecting data, and classifying products, using tools such as the Basel Convention's technical guidelines, the ITU Toolkit on e-waste, the UNITARSCYCLE program, and resources from the Global E-Waste Statistics Partnership. Step 2 includes information on designing e-waste prevention and reduction programs based on strategies developed by ITUT and other international organizations. Step 3 outlines the supportive measures required for ensuring implementation and successfully reaching the Connect 2030 e-waste target. Steps 2 and 3 will be elaborated in the next slide. E-waste has been defined similarly by different international organizations. However, the legislations of most countries refer to electrical and electronic equipment as any device that for functional reasons is dependent on electric currents or electromagnetic fields in order to work properly. It becomes e-waste when the holder discards, intends or requires to discard. Countries can use the United Nations University Guideline on e-waste classification and indicators. United Nations University KEYS, which lends itself to using the harmonized statistical coding of the international trade codes, the harmonized system via the following criteria. It categorizes products based on similar functions and material composition, including hazardous substances and valuable materials and other related end-of-life attributes. Products within the same category have the same average weight and lifespan distributions, which simplify quantitative assessment for similar products. Large e-waste products with lot of data potentially available or assigned separately. Therefore, to develop a comprehensive e-waste inventory. The following e-waste categories could be considered: temperature exchange equipment, large household appliances, screens and monitors, fluorescent lamps, photovoltaic panels, and small equipment, especially IT and telecommunication equipment. That leads into the diagram on this slide on the 6 steps needed to construct an e-waste inventory. It is the base to plan the design of e-waste reduction program. It answers the question of, how much e-waste do we have? In doing so, it considers the volume of e-waste generation in a given country, city or other entity, and the ways in which waste electrical and electronic equipment are managed. There are 2 different ways to estimate e-waste. The market supply methodology looks at what is put in the market and what goes out. Estimation of electrical and electronic equipment put on the market. Amount of electrical and electronic equipment put on the market equals domestic production plus amount of new imports plus amount of second-hand imports minus amount of export. The consumption-based methodology looks at what we have at home. Assessment of the amount of electrical and electronic equipment in use or stored at the consumer level, survey. Private consumer, home. The type and amount of installed electrical and electronic equipment. Average lifespan of each equipment. Size of the household. Income class of the household. Institutional and corporate. Consumer, company. The type and amount of installed electrical and electronic equipment in the organization. Average lifespan of each equipment. Size of the organization. Number of staff. Type of organization, and main activity. Estimation of e-waste generated based on information obtained from the surveys. Amount of e-waste generated, metric tons, annually equals amount of equipment stockpiled divided by average lifespan of the equipment. Step 1 focuses on constructing a comprehensive e-waste inventory. To start with, the market supply approach is detailed here and was successfully applied in ITU ECHO, UNITAR pilot surveys. Main data sources come from existing national tools and statistics, but can be complemented with additional data, such as existing stock of electrical and electronic equipment, annual e-waste generation and collection flows, recycling streams, including formal and informal sectors, data on illegal imports and exports. Data can be collected at multiple levels. Product level, for example, computers. Mobile phones, component and material level, for example, batteries, printed circuit boards, metals, national and regional levels. Household surveys can also be integrated, providing on-the-ground data to validate and refine the inventory. The methodology aligns with the ITU ECHO, UNITAR pilot surveys and has been recognized by the e-waste subgroup of the Expert Group on ICT Household Indicators under the Partnership on Measuring ICT for Development. By starting with this structured e-waste inventory, countries can establish a baseline for policy making, stakeholder engagement, and future e-waste reduction targets. Another method to consider is the use of consumption-based methodologies from the Swiss Federal Laboratories for Materials Science and Technology, in short, EMPA, which is recommended here as a reference point. It is recommended to start with establishing the scenario involving all stakeholders, after which key components should include policy and legislation that are implemented now, stakeholder assessment of who the actors are in the country and their roles. Examples could include manufacturers, importers, distributors, consumers, collectors, refurbishers, recyclers, final disposers, and most affected communities. This is an example graphic representation of the movement, current mass flow, future mass flow, etc. of e-waste as part of Step 1, prior to assessing results and conclusions. This step takes into account the waste hierarchy. At the top of the waste hierarchy is waste prevention, indicating that minimizing both the quantity, total e-waste generated, and the hazardousness, toxicity, of waste is among the most effective strategies employed to tackle waste streams such as e-waste. Waste prevention encompasses components including strict avoidance, source reduction, direct reuse, reuse, and recycling. Waste prevention can be achieved by reducing the quantity of material used in the creation of products, designing and consuming products that generate less waste, as well as encouraging the extension of a product's lifetime. Reuse. Recycling and recovery aim to keep products in the consumption cycle for as long as possible by diverting used products from the waste stream. Disposal is ranked as the last option since common waste disposal practices such as incineration and landfill remain hazardous to the environment and human health. Therefore, the waste hierarchy encourages eco-design and measures. It encourages responsible consumptions and increases the longevity of electrical and electronic equipment by extending the use phase of an electrical and electronic equipment and delaying reaching the end-of-life phase. It advocates for solutions using less materials. And it reduces packaging, though policies regulating packaging wastes. Extended producer responsibility, as has been covered in previous slides. Green procurement for the ICT sector. This slide outlines the basic measures required for successful implementation of e-waste management systems and programs. The recommendation has been adopted in Costa Rica and Argentina, and the following two case studies describe the implementation of this recommendation. Thank you for your participation in this course. We hope you found it informative and that you will join us in other courses that are also part of this series.